our learning goal today is you'll use some difference identities to find the exact value of a trig function. Okay, so we're looking at some new identities. And there are 6 of them, and they're coming up on the next screen, so write these 6 down for me real quick. So we're going to use those to be able to find the exact value of trig functions of angles that are angles we haven't dealt with before. What are the angles we know how to find the exact values of? Special angles and quadrantals. Okay, and we can also do special angles that are in different quadrants using what 2 things? Reference and the quadrant. Using the reference and the quadrant to be able to get it. So those are the angles we know how to get exact values of. Okay, we want to extend that now using our sum of different identities. It's going to allow us to find exact values of some other angles, such as negative 15 degrees. So the first thing I want to do on this one, sine of negative 15 degrees, is take care of that negative. What can I do with the negative that's inside of sine? It moves it out front. Okay, so I can rewrite this as negative sine of 15 degrees. Okay. Now, if you notice everything that we just wrote down on those identities, what was inside of sine, cosine, and tangent? A plus B or A minus B. So what do you think we want to do to 15? We want to split it up into 2 angles I know how to find the exact value of. So what are 2 angles I know how to find the exact value of that are added or subtracted to give me 15? 45 and 30, or I could do 60 and 45. Either way, it's going to give you the same answer. So this is the same as negative sine of 45 minus 30. Everybody agree that 45 minus 30 is the same thing as 15? Mm-hmm. Once I get to this point, I now want to recognize which identity do I want to use. And we're dealing with sine of an angle minus another angle, so what identity do we want to use? Christian?
Would it be sine A plus B since it's negative?
No, we're going to ignore that negative, and we're just interested in what's going on
so
in there.
It'll be sine A minus B.
It'll be sine of A minus B. Now, since there is a negative here, we want to transfer that negative over here. Okay, and then we'll plug everything in. So it's sine of A minus B. So that is, if I plug it in, that's going to be sine of 45, cosine of 30, minus cosine 45, sine of 30. So all I did there was plug it in to sine of A minus B. Any questions on what we did there? Now we're dealing with 4 things over here that I know the values to. So we're going to substitute those values. So what is sine of 45?
1 over square root of 2.
1 over square root of 2. What's another form of 1 over square root of 2?
Square root of 2 over 2.
Square root of 2 over 2. When we're dealing with sum of difference identities, we want the square root to be in the numerator. So square root of 2 over 2 is there. What's cosine of 30?
1 half. Square root of 3.
Square root of 3 over 2 is there. Cosine of 45, square root of 2 over 2. And if cosine of 30 is radical 3 over 2, then that means sine of 30 has to be 1 half. So now I just multiply. So square root of 2 times square root of 3.
Square root of 6.
Square root of 6. 2 times 2 on the bottom is 4. On the top, that's going to be square root of 2. My denominator is 4. Notice my denominators are the same. If you do this correctly, your denominators will always be the same. If your denominators are not the same, you did something wrong. So then I can make this a negative square root of 6 minus the square root of 2 over 4. And what is it that equals the negative square root of 6 minus square root of 2 over 4?
45 minus 10.
Sine of negative 15. What we started with is what equals that. That is my answer. We found the exact value of sine of negative 15 degrees. just like the exact value of sine of 30 is 1/2, the exact value of sine of negative 15 is negative square root of 6 minus square root of 2 over 4. All right, let's try another one. Cosine of 75. We want to find the exact value of cosine of 75. So what? Split it into two angles. What two angles do you want to use?
45.
45 and 30. So which identity do I want?
Cosine of A plus B.
Cosine A plus B. So that is cosine 45, cosine 30. Thanks for coming in, Hunter.
Thank you.
Minus sine 45, sine of 30. Any issues with that? All I did was plug it into the formula. Now I go in and evaluate each one of these. So cosine of 45 we know is square root of 2 over 2, cosine of 30. Square root of 3 over 2, sine of 45,
Square root of 2.
square root of 2 over 2, and sine of 30. 1/2. Okay, so we notice both denominators are going to be what? 4. And in my numerator, I'm going to have square root of 6 minus the square root of 2. And what is it that equals the square root of 6 minus square root of 2 over 4? Cosine of 75. So the exact value of cosine of 75 is the square root of 6 minus the square root of 2 over 4. Now, in the first hour, somebody noticed something at this point. That is very similar to what we got on the last one. The last one was a negative square root of 6 minus the square root of 2 over 4. So somebody explain that.
Because when you have a number that's, or when you have an angle that's negative, it goes the other way to the quadrant.
That's because the reference angle's to 90. Maybe.
All right, and be more specific.
The co-function identity.
All right, sine and cosine are co-functions, and sine and cosine will equal each other when what happens? Their angles add up to 90. So what's going on with 15 and 75? They add up to 90. So that's why I get the same value. The other one's just negative because of that negative 15. So that's why these two are the same. Very good, Nick. Next one. Sine of 11 pi over 12. Sine of 11 pi over 12. Right, but what do you want to do first?
Change it to degrees.
Change it to degrees. Anybody know how much pi over 12 is going to be worth? How much is pi over 12 worth?
Oh,
Is it 15 degrees?
15 degrees. Why is it 15, Kathleen?
Well, 30 is pi over 6.
Pi over 6 is 30. So pi over 12 is half of pi over 6, so that means it's going to be half of 30. So I need 15 times 11. What's 15 times 11?
A lot.
You guys should be able to multiply by 11. Can you guys not multiply by 11?
It's the 15.
Didn't need to know that about 12.
We learned so much complex stuff and just
It's just gone now.
it's gone. It's gone. See, you can ask me that now I'm thinking about variables and what this is like.
Alright, so now what do I do with sine of 165? Split it up. What do you want to split it up into?
Obviously, we know it's going to be.
One of them has to be,
Well,
90.
90. No.
The quadrant.
180.
what?
one of them has to be 45.
Yeah.
Why does one of them have to be 45?
There's 5.
Because it ends in a 5. Yeah, if it ends in a 5, one of your angles has to be 45. So what do I do to figure out the other one?
Subtract 45.
Subtract 45 from 165, which gives me 120. We can do that.
I was gonna say we know we can we're gonna do sine of A plus B.
Okay, so it is sine of A plus B. So that means we want sine of 45, cosine of 120, plus cosine 45, sine of 120.
Oh, because it's
So let's do the 45s real quick. Both of those are what? Square root of 2 over 2. But in order to do cosine of 120 or sine of 120, what do I want to do first? What do I need?
reference.
And
Quadrant.
quadrant. So I need the reference angle and the quadrant. So let's start with the quadrant. What quadrant is 120 in? 2. And what is 120's reference angle? 60. How do we know it's 60?
180 minus 120 is
Yeah, it's 60 degrees away from 180. So we're going to know how far is it away from the x-axis. So it's 60. So now I want cosine of 60. What's cosine of 60?
square 3 over 2.
1/2. If this is 1/2, what does this one have to be? Square root of 3 over 2. Alright, and then I need cosine in the second quadrant. Negative. And I need sine in the second quadrant. Positive. So now we're ready to multiply. So that gives me, we know my denominator is going to be 4 again. I have negative square root of 2 plus the square root of 6. And what is it that equals that?
Sine
Sine 11 pi over 12. So the exact value of sine 11 pi over 12 is negative square root of 2 plus the square root of 6 over 4. And a lot of these numbers are going to look the same. Why are they going to look the same?
This is the same first one.
Because we're using the same stuff. We're using 1/2, we're using radical 2 over 2, and we're using radical 3 over 2. So if we use the same stuff, the answers are going to look similar. Next one. Now let's do a tangent. So I want to do tangent of 23 pi over 12. So what do I want to do first? Change it 2 degrees. So I need 15 times 23.
345.
345.
That's okay.
45.
Has to be 45. What's the other one going to be? 45 and 300. So we notice it's tangent of A plus B. So I want tangent of 45, bless you. Tangent 45 plus tangent of 300 over 1 minus tangent 45. Tangent 300. All right. So let's do the tangent 45s first. That should be easiest. What's tangent of 45? 1. So I'll put a 1 in both of those spots. Now, to be able to do tangent of 300, what do I need? So my quadrant is 4, and my reference angle is 60. So what's tangent of 60? Square root of 3. So I'll put square root of 3 in both spots. And then is it positive or negative? It is negative. Because what is my letter for quadrant 4? C. So those have to be negative. So I'll clean that up a little bit. I have 1 minus the square root of 3 over 1 plus the square root of 3. And what is it that equals that? Tangent of 23 pi over 12. Okay, it's just a matter of plugging in and evaluating your trig functions. Alright, now what do you think they want us to do on this one?
Simplify.
Simplify. They want me to go back the reverse direction. So tangent of 43 minus tangent of 13 over 1 plus tangent of 43 tangent of 13. So what is this?
Oh, it's
Tangent of
a.
It's A minus
A minus B. So this is equal to tangent of 43 minus 13, which is equal to tangent of 30. And what is tangent of 30 equal to? Square root of 3 over 3.
Do that easy.
So this ugly thing is equal to radical 3 over 3. So it's going in the reverse direction.
That's it.
That's it on that.
That's it.
You got two more.
Oh my goodness, wow.
Cosine of 40 times cosine of 20 minus sine of 40 times sine of 20.
That is
So that's cosine A minus B.
Cosine of A plus B. So this is cosine of 40 plus 20, which is cosine of 60, which is 1/2. So that
So
long thing at the beginning is the same thing as 1/2.
So if cosine then it's minus, that means it's cosine of A plus B. Okay.
Alright, last one. Cosine of x, cosine of 2x, plus sine of x, sine of 2x. So I want to simplify
So
this.
that's
It is cosine of X plus 2X.
Cosine of A minus B. So it is cosine of x minus 2x, which is cosine of negative x, which is cosine of x. Okay, we don't want to leave a negative inside. What's going to happen with the negative? What are my two options?
It goes away.
It goes away or it goes out front. Since I'm dealing with cosine, it goes away. So this is equal to cosine of x. That big thing simplifies to cosine of x using the sum of difference identities. Wow. Can I get what? Because I
How'd you
had
get the other
x
sign to go away?
and 2x.
That's what happens, and that's the rule of cosine and secant.
What'd you say?
What about sine? Why
You
did we
just
not
know
look
that.
at that?
I'm glad you mentioned that. Usually somebody does. But if I go back to the beginning, I've got this is equal to that. So when I go down to the end, that means this is equal to cosine of x minus 2x using that formula. Just like 1 minus sine squared is equal to cosine squared, whenever I see 1 minus sine squared, I can replace it with cosine squared. Same thing here. Whenever I see this, I can replace it with that.
Okay,
So this whole thing turns into that because of the identity.
got it.
Glad you asked that question, because you're not the only one thinking. Alright, page 341, 246, 12 through 22, and I'm going to change number 2 actually, because I don't like it.
So don't do 2 or you're.
I'm gonna give you a different one to put in 2's place. And that is going to be sine of Okay, so I want you to do sine of 315 instead of number 2. So put sine of 315 instead of number 2 in there.
Okay.
Okay.